Hey everyone, this is the Math Nexus, and today at last we have completed exercise 1.5 and are proceeding to exercise 1.6 of O level and IGCSE additional mathematics. So, the main objective of this lecture is to counter exercise 1.6, and what this exercise talks about is inverse functions. So, we have already discussed about functions and the graphs and modulus functions. There are various types. Okay, now it's a level up. It's inverse functions. Okay, inverse functions. And as you can guess by the name, inverse means the opposing side, or in fact the opposite. Okay, so that names give us the fact that whatever function is, its opposite is its inverse function. Okay, so and whenever you see any function in this form, there is a inverse. So this is the form to write inverse function. Okay, so whenever you see this form, you say that this equation is an inverse function. Okay, so basically what an inverse function does, it undoes, as written in the book, it undoes what the function has done already. So thing is, in simple words, it's the opposite of a function. For example, the function of x is 2 plus x. Okay, so what should it inverse? What is the thing that will undo this plus x? Some thing is being added into x, and what will make that addition? For example, that addition is causes our answer to become something like 7. Okay, so what will be the thing that will make 7 go to the original x value? Okay, that's minus 2. If we say x minus 2, and or you can say, if you are getting confused about that, we can say 7 minus 2. We will again get the value of x. That's what an inverse function does. It reverses what a function has already done. Okay, if in this example we see that 2 is added into the x value, which gives out 7. Okay, as the answer. And then if we subtract 7, when we subtract 2 from 7, we get the value of x. So what's happening? It's reversing what the function has already done. So that's the main concept of a inverse function. And whatever is in a function is reversed. So the domain it becomes the range in an inverse function, and the range becomes the domain in an inverse domain. And what we have discussed, that the domain is the set of inputs, and the range is the set of outputs. Range is the set of outputs. Okay, and from this thing we get to know that the input we give in a inverse function, yes, is actually the range of the function itself. Okay, it's a little bit confusing, but let me explain it more clearly. The output that we get from a function is the input for the inverse function. You get my point? We are getting 7 as the output of a function, and we are inputting it into the inverse function so that we can again get the function. It's a little bit confusing, but please try to concentrate. So we can say that the output of an inverse function is actually what we have already input into the function itself, if you get my point. Because we have the output of an inverse function. This is the inverse function. Okay, and we have got the output to be x, and this output is actually the input in the function. We can see that 2 plus x is the input in the function. So that's the thing. The input in a function is the output of a inverse function. Is the output of an inverse function, and the output of a function is the input for an inverse function. That's simply it. And I know it's looking a bit confusing for now, but as we solve the questions, and we will have good knowledge over it. So when there's a function x, okay, whenever there is a 1-1 mapping, okay, 1-1 mapping, a function can exist in that form. Okay, 1-1 mapping means for one input we get one output. So that means for a one many mapping or a many one mapping, we have no inverse. Same for the one many. That means if we input two values and get, yes, so that means if we input two values and get out one value from it, that means this is not a this function cannot have an inverse. Okay, and again similarly, for if you give one value and get two outputs, that means again our function cannot be an inverse. One input, you get two outputs. This is not a inverse function, an inverse function. Okay, clarified concepts. One thing just needs to be explained now is that how do we find the inverse of a function? It's kind of, you know, it's mathematical, but it's like you have to learn the steps. So the thing is, you first, whatever your function is, for example, you have the function, I will start, okay, just a basic function, 2x minus 5, okay? This is what we call the function of x in terms of x, okay? How do we find its inverse? How do we find it? Okay, the thing we do is, and from the starting of this chapter, we are assuming that, especially in the graphical stages of this chapter, we assume that y is equal to fx. So we consider y is the function of x, and then we say y is equal to 2x minus 5. Okay, y is equal to 2x minus 5. We just assume the function of x to be y. Okay, simple. It's easy till then. And the next thing we do is switch the x and y values. Okay, that means wherever there is a y, we say there is a x. So x, and wherever there is a x, we say it's a y. 2y minus 5. Okay, that's what we do. This is because we are actually reversing all the whole equation. Okay, and that's how it works. So now again, we have reversed the equation, and this y actually now represents the function, the inverse of x. I know it's a little bit confusing, but you will get to know it as we solve more questions. And what we now need is to make y the subject. So step 1, we have to write y is equal to fx, and then we say that y is equal to 2x minus 5. Okay. Step 2, we have to change the x and y values by switching them. Make the x value the y value and the y value the x value. Okay. And the third step we do is rearrange the whole equation so that y becomes the subject. So what will that need is x plus 5 divided by 2 is equals to y. So that would actually mean that the function, the inverse of x is equals to x plus 5 upon 2. Simple. So we take the y value to be the inverse of x in the end. And that's how you find the inverse of any function. It may seem a little confusing, but as we go through the questions, it's going to make a lot of sense. So on to question number 1 of exercise 1.6. So what question number 1 says is fx is equals to x plus 5 whole squared minus 7 plus 5 whole squared minus 7 for x is greater than equals to minus 5. And this value is not so important in this question. However, it allows us to check if, you know, our final answer is correct or not. So they are important, but after we solve the question. So find the expression of f inverse of x. So it's simple. From expression, they means find the, you can say the equation or anything, but we just have to find the inverse of this function. So how do you find the inverse? First say y, switch y and function of x, and say that y is equals to x plus 5 whole squared minus 7. The second step is to interchange the x and y values. So x is equals to y plus 5 whole squared minus 7. And the third step is to make y the subject of the equation. So x plus 7 is equals to y plus 5 whole squared. In order to remove the square from this side, apply under root to both sides. So under root x plus 7 is equals to y plus 5. So next step is under root x plus 7 minus 5 is equals to y. And that's the function of f. Pretty simple. So on to question 2, which tells us that the function of f is such that 6 upon x plus 2 is the equation. So again, find the inverse of this function. That would give us y is equals to 6 upon x plus 2. Interchange the y and x values. X is equals to 6 upon y plus 2. And then what you do is make y the subject. So x, y, no, but it's no need to do this. X multiplied by y plus 2 is equals to 6. So y plus 2 is equals to 6 upon x, and y is equals to 6 upon x minus 2. So this is for the part 2, but you can also do in this form: 6 upon x minus 2x, sorry. So that would be the same because we have taken the LCM. Let me make this x in the middle. This is because we have taken the LCM. We had multiplied the 2 by x to make it conversion into the fraction form. Okay. Okay, for question number 3, we have fx is equals to 2x minus 3 whole squared plus 1. So we have to find the inverse of this function. And what we do for that is just assume the value of the function f to be y, and we say y is equals to 2x minus 3 whole squared plus 1. And what we do again is interchange the x and y values. So x is equals to 2y minus 3 whole squared plus 1. So x minus 1, in fact, under root x minus 1 is equals to 2y minus 3. Under root x minus 1 plus 3 is equals to 2y. So, and the last step, x minus 1 plus 3 divided by 2 is equals to 1. And that's it. That's the answer for question number 3. These are really short questions because they are actually the basics, literally the basics. And we will just continue with question number 4. So, okay, for question number 4, we have fx is equals to 8 minus under root x minus 3. Find the expression for f inverse of x. Again, we have to find the inverse of the function. So what we do is assume fx equals to y, and y is equals to 8 minus under root x minus 3. Similarly, what we are going to do is we are going to interchange the x and y values. So x equals to 8 minus under root y minus 3. Next, we are going to say that x is equals to, oops, not that. We're going to say that we're going to say that x minus 8 is equals to minus under root y minus 3. And in order to simplify it, we are going to take this negative sign and put this here. So cut this down from here, put this here. So minus x minus 8. So we are going to say it's going to become 8 minus x is equals to under root y minus 3. By the way, it's going to become 8 minus x because we are going to get minus x plus 8 from its output. Minus x minus minus plus and plus 8. And we are going to rearrange this. So those of you who don't know that. So 8 minus x whole squared is equals to y minus 3. And 8 minus x whole squared plus 3 is equals to y. And we can similarly say that the inverse of the function f is equals to 8 minus x whole squared plus 3. And that's our answer. Now proceeding towards question number 5. We have been given a similar equation, fx equals to f5x minus 3 and gx equals to 7 upon 2 minus 6. So right now we have to find the inverse of the function f and the inverse of the function g in terms of x. Okay, so what we do next is, first of all, find the inverse of the function f. So y is equals to 5x minus 3, as you know, and interchange the values, x equals to 5y minus 3. So x plus 3 is equals to 5y and y is equals to x plus 3 divided by 5, which in return is equals to the inverse of function f. Similarly, for the inverse of the function g, we are going to say that y is equals to 7 upon 2 minus x, and what will be next? Interchange the x and y values. So x equals to 7 upon 2 minus y. Okay, make a line here, and 7 minus 2, 7 upon 2 minus 5. Next step, what we are going to do is x multiplied by 2 minus y is equals to 7. So 2 minus y is equals to 7 upon x minus y is equals to 7 upon x minus 2. Y is equals to minus 7 upon x plus 2. And you can simplify this to say 2 minus 7 upon x is equals to y, which in return is equals to g inverse of x. And that's our answer. We can also simplify this into, like, take the common LCM, 2x minus 7 upon x. Let me scroll this down. Okay. 2x minus 7 upon x is equals to this. Okay. It's just taking the LCM, no big changes. Okay. Okay. The next question we have question number 6, which tells us that fx is equals to x plus 2 whole squared minus 5. Okay. And now, right, we have to find the inverse of this function. So let's concentrate on part f only. Part A only. So it's going to become y is equals to x plus 2 whole squared minus 5. Interchange the x and y values, x equals to y plus 2 whole squared minus 5. Similarly, this will be simplified. X plus 5 is equals to y plus 2 whole squared. So under root x plus 5 is equals to y plus 2. Similarly, x plus 5 in an under root, in a under root, minus 2 is equals to y. And that's the inverse of our function A. And what they demand us from part B? Let's see. They tell us that we have to solve the equation that f inverse of x is equals to 3. Now, many people have seen do the mistake that they input the value of x in this equation to be only the x input should be 3. It's not that case. They are saying that the whole equation is equals to 3. So we are going to say that for part B, x plus 5 minus 2 is equals to 3. And that's what they demand. So we have to just solve this equation. Simplify this. X plus 5 is equals to 3 plus 2, which is 5. Minus 2 will go there. It will become positive 2. So 3 plus 2 is equals to 5. To remove the under root here, we have to bring a squared on both sides. So x plus 5 is equals to 5 squared is 25. Okay. And what we're going to do next is x is equals to 25 minus 5. And x is equals to 20. And that's it for question number 6, part B. Really, it's that simple. Okay. For 7, let me erase this. And I think this much space is more than enough. Let me just erase the whole row. Okay, so question number 7 tells us that fx is equals to x plus x minus 4 whole squared. Fx is equals to x minus 4 whole squared plus 5. Okay, now we have to find the first part, the inverse of this function. So simple, y is equals to x minus 4 whole squared plus 5. As we are doing, interchange the x and y values again. X is equals to y minus 4 whole squared plus 5. Okay, now what we do next is simplify this equation to make y the subject. So x minus 5 is equals to y minus 4 whole squared, and we don't care what the other thing but becomes. We just have to make the y a single y. So we have to just make it the subject. So we make this under root x minus 5 is equals to y minus 4. If you don't understand it, this is basic maths. In order to remove a square from one side, we have to put a under root on both sides. And if we put under root here, the square will be cut down along with the under root. Okay. So, okay. Now next, what we are going to do is under root x minus 5 plus 4 is equals to y. And that's it. This is our inverse of the function f. So that's it. Now the next thing we have to do is solve the equation f inverse of x is equals to f0. And that's is actually, if we write x minus 5 under root plus 4 is equals to, we have to write the whole function of f and just input the value of x to be 0. So input 0 into the whole equation of f. 0 minus 4 whole squared plus 5. These two are equal. So just solve this and find the x value. Simple. So x minus 5 plus 4 is equals to minus 4 squared is 16, positive 16. 16 plus 5. So under root x minus 5 is equals to 16 plus 5 is 21. Okay, and 21 minus 4 is equals to 17. So 17 is here. So x minus 5 is equals to 17 squared. And let me put this into this calculator. 17 squared is equals to 289. X minus 5 is equals to 289. X is equals to 289 plus 5, which becomes 294. So x is equals to 294. That's our answer for part 7. And that's it. For question number 8, we have, let me go in front. Okay, for question number 8, we have gx is equals to 2x plus 3 divided by x minus 1. A similar question again, just a little bit more complex, a little bit. So x minus 1, and we have to find the expression for the inverse of this function. So, okay, question number 8, we have to write this as 8. Okay, so again, y is equals to 2x plus 3. That's the first step. Interchange the values. That's the second step. 2y plus 3 divided by y minus 1. Okay. Now, many people become confused because there are two y values and they are both dividing from each other. So it's kind of, many people find it really confusing how to make the y subject without having another y on the other side of the equation. So what we do is, first of all, we multiply this by x. X y minus 1 is equals to 2y plus 3. We are just simplifying the equation right now. No methods, no nothing, just simplifying it. Okay. Xy minus x is equals to 2y plus 3, and that will become xy minus 2y is equals to x plus 3. And you can notice that I'm trying to just isolate the y values to one side and other values to the other side. So x plus 3, yes. Take y, the common from this, y x minus 2 is equals to x plus 3. And the next step, y is equals to x plus 3 divided by x minus 2. This is our inverse of the function g. Okay, so that's it. What does part B demands us? It's similar to what we have been doing till now, and it's telling us that solve the equation, the g inverse is equals to 5. And let me make this line here. what we are going to do is we're going to say that x plus 3 upon x minus 2 is equals to 5. So that will become x plus 3 is equals to 5x minus 10, because 5x multiplied by 5 multiplied by x minus 2 is equals to 5x minus 10. Similarly, x minus 5x is equals to minus 10 minus 3, minus 4x is equals to minus 13. Cut down the negative values, x is equals to 13 upon 4. So x is equals to 3.25. You can easily find this through a calculator. Okay, for question number 9, we have fx is equals to x upon 2 plus 2. And wait a second, please. Just let me do one thing. Okay, so what we do is we. Oh, I'm sorry, I was just getting confused a little bit. So find the function, the inverse of the function y is equals to x upon 2 plus 2. Interchange the x and y values, x is equals to y upon 2 plus 2. Make y the subject, x minus 2 multiplied by 2 is equals to y. We can also say this is equals to 2x minus 4. Okay. And we can say that this whole is actually the inverse of function f. And that's it. So it's that easy. And what we are going to do is, just let me clear up some space for part B. And I think I'm going to clear all of it. Just bear with me. Okay. For part B, what they have asked us is we have to solve the equation f(g(x) is equals to the inverse of function f. So right now we have to first find out what f(g(x), and I have explained in the previous lectures how to find function input into a function. So I won't be explaining it in detail right now. For that, you have to check my previous lectures. I think it's exercise 1.1 or 1.2, something like that. For now, we have to solve question number 9, part B. And now input the value of the function g into the function f. So instead of the x in function f, we have to write the function g. So x, instead of x, we are going to write x squared minus 2x divided by 2 plus 2. And that's it. What we are going to say is it's equals to the inverse of f. And what have we, the inverse of f? Let me see what have we found as the inverse of f. I just erased it off. No, I have right now solved it. 2x minus 4, yes. We have 2x minus 4. Okay, so what we do is simple. X squared minus 2x, we just have to simplify this right now. Is equals to 2x minus 4 minus 2. X squared minus 2x divided by 2 is equals to 2x minus 6. And x squared minus 2x divided by, x squared minus 2x is equals to 4x minus 12. Okay. So simplify this again, x squared minus 2x minus 4x plus 12 is equals to 0. Simplify this, x squared minus 6x plus 12 is equals to 0. Okay, another thing I will right now, you know what I will do? I will just attach a video, or I will also upload it in the description. So that you can use a video that will tell you how to use your calculator to find out the answers for quadratic equations. So right now we are going to go to mode setup, 5 equation, and third is for quadratic. If you don't understand what I'm saying, I will just link a video in the description, and you may also see it in the top right corner. So what we do is 1 minus 6 and 12 Now the answer is 3 plus under root 3 iota and 3 minus under root 3 iota. And I've discussed in the previous lecture that iota is not in our curriculum right now. And apart from that, we can see that we are getting lower. So we are going to say that we do not have any solution and A, not applicable right now. And that's our answer, no solution. Okay. For question number 10, okay. So what's for question number 10? It's telling us that fx equals to x squared plus 2. Okay, and okay, why I'm getting confused. So x squared plus 2. So we have to solve the equation g of x is equals to g inverse 17. So right now it's demanding us to things. First of all, we have to find the inverse of the function g. So the inverse of function g is y is equals to 2x plus 3, x is equals to 2y plus 3. X minus 3 divided by 2 is equals to 1. That's the inverse of the function g. Okay. What's g f x? Input the value of the function f into the function g. So instead of x, we are going to write 2x. Sorry, we are going to input it into the function f. So instead of 2x, we are going to say 2 multiplied by x squared plus 2 plus 3. Okay, is equals to g inverse 17. So we have to input the value of 17 in the function g inverse, which is the inverse of the function g. So 17 minus 3 divided by 2. Okay. Now simplify this. 2x squared plus 4 plus 3 is equals to 17 minus 3 is 14. 14 divided by 2 is 7. So 2x squared 4 5 6 7. So is equals to 7 minus 7. Okay, these both add up to 7 and they are going to be subtracted after they move here. So 2x squared is equals to 0, x squared is equals to 0, 0 divided by 2 is 0, and that's why x is equals to 0. So x equals to 0. That's our answer for question number 10. Okay, on to question number 11. Okay, so for question number 11, we have fx is equals to 2x plus 8 divided by x minus 2. And we have the value of gx to be x minus 3 upon 2. Okay, so we have to solve the equation. The function of x is equals to the inverse of the function g. So first of all, find the inverse of the function g. What it is not directly. I'm just going to make it direct. I think I've explained it enough that you may understand it now. What I'm doing, I'm just directly jumping on to the second step. I'm not assuming. I'm not using the first step right now. So I'm directly interchanging the x and y values. So x equals to y minus 3 upon 2. I hope you understand this. It's actually directly I'm going on to the second step right now. I'm directly interchanging the x and y values. X is equals to y minus 3 upon 2. I'm not doing step 1 right now. It takes space. So 2x is equals to y minus 3 and 2x plus 3 is equals to y. Equals to y, which is in return equals to the inverse of function g. Okay, so that means we are going to say that 2x plus 8 divided by x minus 2, 2x plus 8 divided by x minus 2 is equals to 2x plus 3. Okay, just quickly simplify what's in this equation. 2x plus 8 is equals to 2x multiplied by x minus 2 and plus 3 multiplied by x minus 2. Simplify this. 2x plus 8 is equals to 2x squared minus 4x plus 3x minus 6. 2x squared minus 4x, and we are going to take 2x minus 2x plus 3x minus 6 minus 8 is equals to 0. simplify this again to x squared. Minus 4 minus 2 is minus 6. Minus 6 plus 3 is minus 3x. Minus 6 minus 8 is minus 14, which in return equals to 0. So we are going to get two values after we input into our calculator. Mode setup 5, 3. Don't worry, I'm going to add a link in the description so that you can solve quadratic equations easily. So 2 minus 3 and minus 14, which gives us 7 upon 2, which is equals to 3.5. X is equals to 3.5 and or x is equals to negative 2. Okay, so that's for question number 11. If I make a line here, I am going to solve question number 12. So it's looking simple. We have been told the function of x is, I'm getting too much to the corner. Let me just leave on that. Question number 12. Fx is equals to 3x minus 24. For x is greater than equals to 0, write down the range of f inverse. Okay, so this is interesting. I think, yes, I have already told you the answer to this part in my introduction of this video. And the thing is, I've told you whatever, and if you don't get it right now, and if you just jumped right into this question, I would suggest you look at the intro of this video and you will understand this more clearly. The thing is, I've told you in the starting of the video that the input of a function is actually the output of an inverse function, and the output of a inverse function is actually what we have already input in the function itself. So I've explained it in great details with examples in my intro, so I would suggest look at it. So that means we can say that the domain of a function is actually the range of a inverse of the function, and the range of a function is the domain of the inverse of the function, because domain and range are actually the inputs and outputs. We can say domain is the set of inputs, range is the set of outputs. And similarly, we can say that right now x is greater than 0 is actually the domain, meaning the set of inputs that can be given into the function f. So x is greater than 0 is the domain, and they have told us to find the range of the inverse of f. So the domain of the function is the range of the inverse. So right now we have the answer in the question itself, and we are going to say question number 12. We are going to say that for explanation, and so that the examiner has a good impression that we have understood, we are going to say as the range of a function, as the range of an inverse is actually the domain of its function, we can say semicolon. What we can say is that the inverse of the function f is greater than equals to 0. So we are just answering the question by looking at the question. So that's really simple. Okay, so, and if you have not understood this clearly, again I'm going to tell you to go to the intro. I've explained it in great detail there. So okay, so question number 13, we have fx is equals to x plus 6 and gx is equals to under root x. And what they're telling us is to express in terms of f and g, tell what x in terms of x squared minus 6 is. We've done this in the previous lectures. Again, I'll just give an intro what we need in this. We need to find out in terms of f and g, what would be the equation that would help us to form x squared minus 6. Okay, so if you see right now, we need a x squared. Okay, and if you concentrate right now, we do not have any x squared, and nor do we have x minus 6. We have the opposite of that. That means we have to find the inverse of these two. Okay, because what we need does not fulfill our requirement. So what we are going to do is first find the inverse of the function f. We are going to say that this will be equals to x is equals to 5 plus 6. I've done it directly. X minus 6 is equals to y is equals to the inverse of function f. And similarly for the inverse of the function g, we have under root x is equals to, under root y is equals to x, and x is equals to y squared. Y is equals to x squared, which in return is equals to the inverse of the function g. Okay, so that's it. What we are going to do now is find what would be the equation that would form what we have required in the equation. So x squared minus 6. Okay, so that means the base equation should be x minus 6. And what we have in x minus 6, we have f inverse of x. So right now, if you just concentrate here, that if we input the value of the inverse of the function g into x minus 6, what will be the answer? That would mean that we would just replace the x of the function, inverse of the function f, with the answer of what it is the inverse of g. So if we input the function g into the function f, so f inverse, the inverse of function f is going to get the value of the inverse of function g, which would give us, instead of x, we are going to write x squared and continue with the equation. So x squared minus 6. So we are going to say that our answer is f inverse g inverse x. And that's it. That is our answer for question number 13. It's that simple. Okay, so if we just proceed on to question number 14, what does this ask us actually? So state which of the functions f, g, h has an inverse. So we have three equations, and they are telling us which of these have an inverse. So we have discussed in the intro. If you haven't seen the intro, I would suggest see it. I have explained every concept that is going to come in this exercise there. So see the intro. What we are going to say is, we have discussed earlier that the inverse can only exist if the function has a 1-1 mapping. That means if a function is given one input, it will give out one output. Okay, only in that case a function has an inverse. Okay, so so if we say, for example, 3 minus 2x, in this equation, if we input 3 minus 2x is equals to fx, and we say that if we, for example, input one value, 3 minus 2 multiplied by 2 is equal to f, we will get only one output, which will be in the form 3 minus 4, which is negative 1. One input, one output. That means that this can have an inverse. Sorry. Okay, so we are clear that the function f has an inverse. So we are going to mark a tick here. For gx, we are going to say that 3 minus 2x in a modulus. Okay. However, there's a limitation in this. Whenever we open 3 minus 2x, we are going to say 3 minus 2x is equals to whatever the value. We can assume, for example, this gx to be equals to y. So we are going to say 3 minus 2x is equals to y. And if you open this, we are going to get 3 minus 2x is equals to y, or 3 minus 2x is equals to negative y. I have explained this method in it's exercise 1.4, I guess, in which modulus functions are discussed. So for one input value of x, and we are getting two output values. Even though it's negative and positive of the same value, it's still two outputs value. If it would have been, for example, y plus 2 and y plus 2, sorry, y minus 2 here. So that would have given us a completely different answer. So that's why this is giving two outputs for one input. So that means we are going to mark across it. This it cannot have an inverse because this does not have a 1-1 mapping. For hx, however, we have 3 minus 2x, and in order to open 3 minus 2x, it's simple. We just say, for example, it's equals to 1. We just say 3 minus 2x is equals to 1, and whatever input value of x will be put into it, it will multiply here, and then it's going to be a positive. It can, if for example x is equals to 2, so we are going to say 2 multiplied by 2 is 4 is equals to 1, and 3 minus 4 is equals to 1. Okay, and if you solve this, minus 1 is equals to 1. So as you can see, for one input we are getting one output. So again, this is a tick. We can say in our final answer that the answer is hx and gx as an inverse, and that's it. That's our answer to the question number 14. Okay, let me just raise this a little bit. Now we have to do question number 15, and what this question number 15 asks, it has given us the function of f, which tells us that x squared plus 2 is, okay, the function f is x squared plus 2, and the function g is 5x minus 4. So right now we have to find the domain of the inverse of the function f, and I've discussed this already, that the domain of the function inverse of any function is actually the range of the function itself. So no need to find the inverse first and then input the range and then find the domain. There's no need. What we are going to simply do is input question number 15. We are just going to simply find the range of this function first. Okay, so we have been given the domain. What we are going to do is find the range. Fx equals to x squared plus 2. And to find the range, we have been given the most minimum value of x, which can be 0. So we are just directly going to input 0. 0 plus 2 is equals to 2. So 2 is the most minimum range of the function f. So the range is actually the domain of the inverse of a function. So f inverse of x is greater than or equals to 2. That's the answer for part A. And part B, it's clearly in the question itself. They've told us to find the range of the inverse of the function g. And it's simple because the function g has a range and it has already given us the domain. The function g has the domain. And the domain of the function is actually the inverse. What's happening? So it's actually the inverse. I'm confused right now. Wait, please. So the domain of a function is actually the range of the inverse of its function. So right now we have already been given the domain and we have been asked the range. So we are just going to say that the inverse of the function g is greater than equals to 0. That's the range. Simple. It's given in the question itself. Okay, that's for part A and B for question 15. Proceeding to question number 16. And question number 16 is the same as we have been doing till now. They've given us the function f and the function g, and they have told us to first of all find the inverse of both of these functions. So question 16a, to find the inverse of the function f, what we do? We say that 3x minus a is equals to y, and x is equals to 3y minus k. Okay, and just simplify this, make y the subject, x plus k divided by 3 is equals to y, which in return is equals to the inverse of the function f. That is our inverse of function f. So inverse of the function g, what it is? Again, x is equals to 5y minus 14. I'm directly jumping on to step 2, divided by x plus 1. And if we just simplify this by making y the subject, so x squared plus x is equals to 5y minus 14. Okay, x squared plus x is equals to 5y minus 14. And I think I've done a mistake. I'm sorry, I'm sorry, I'm sorry. The mistake is that in a hurry I have written x plus 1. In fact, it's y plus 1. Okay, so now what we're going to do is xy plus x is equals to 5y minus 14, and we just really quickly simplify this. So xy, take both y values on the other side, minus 5y is equals to minus x minus 14. Take y as the common, y x minus 5 is equals to minus x minus 14. So y is equals to minus x minus 14 divided by x minus 5. And if you want great detail in subtraction, this is actually the correct answer. You can also write in the form by taking minus as the common, x plus 14 here, and then again taking minus at the common here. So minus x plus 5. Cut down both these minus, we can also say that y is equals to x plus 14 divided by 5 minus x. So that can also be the answer. Okay. So that's for question number 16, part A only. For part B, what have they told us? They have told us find the value of k for which the inverse of function f 5. They're telling if we input 5 in the function of f, inverse of the function f, we get 6. So again, what we do is we know x plus k upon 3 is the inverse of function f. Instead of x, we are going to input 5 plus k divided by 3 is equals to, as this is, 6. 5 plus k is equals to 6 3 is 18. K is equals to 18 minus 5. And k is in return equals to 18 minus 5 is 5, 8, and 8 plus 5. Okay. So it's equals to 13. Okay, so that's for part B, k is equals to 13. Okay, let me erase this to just have some space for part C. Let me erase the whole thing. Okay, so part C, let me remove the eraser. So for part C, we have to input the value of gx into its inverse. So simply, first of all, we have to write what was the inverse of the function g. We had found it out. It was x plus 14 divided by 5 minus x. Okay, so it was in this way. Now what we are going to do next is input the value of gx into this whole equation. Now we'll try to be neat as possible. So instead of x, we are going to write 5x minus 14 divided by x plus 1. Put this into a bracket plus 14. Okay, and divide this whole by 5 minus 5x plus 5x minus 14 divided by x plus 1. Okay, simplify this. 5x minus 14 plus 14x plus 4. Again, I'm telling you we are taking the LCM in this case. Wait a second. Plus 14. You're taking the LCM for multiplying 14 by x plus 1. So what you do next is divide by x plus 1. Again, divide here, and 5 minus, first of all, open the bracket, 5 minus 5x plus 14 divided by x plus 1. Again, take the LCM here. Make a line. 5 minus 5x minus 14 plus 14x plus 14, again divided by x plus 1 divided by 5 multiplied by 5x plus 1 becomes 5x plus 5 minus 5x plus 14 divided by x plus 1. We have taken the LCM, multiply x5 multiplied by x plus 1. So simplify this. 14x and sorry, minus 14 and 14 are cut down. 5x and minus 5x are cut down. 5x plus 14x is equals to 19x upon x plus 1 divided by 19. 5 plus 14 is 19 divided by x plus 1. So now most of you would not know that, I think, but it's a mathematical rule that whatever is in the second step in the division should always be in the denominator. Okay, in this format I'm talking about, it's going to multiply with the denominator. So 19x upon 19 multiplied by x plus 1. Okay, it's going to be in this one, and whatever is in the last, I mean the last of the letter, or you can say the fourth stage, third, fourth here. So it's on the fourth stage, it's going to go up and multiply with the whole equation, so x plus 1. Okay, so it's in this form. It's mathematical logic. Okay, you have to follow the rules of mathematics. Okay, we're sort of doing maths right now. So multiply this, x plus 1 and x plus 1 will be cut down because they're multiplying there. What we do next, actually they're dividing it upon. So 19 upon 19 will also be cut down, and our answer would remain as answer is x. And after so much, we are getting our answer x. Okay, so that's for question number 16, sorry. And what we are going to do next is we are going to solve question number 17. And question number 17, as I've told you, these type of questions need a lot of practice. And as we can see, what they have asked us is, they have given us fx equals to x cube and gx equals to x minus 8. And they have given some expressions and told us to find them using only f, g, f inverse or g inverse. So we have f and g. First of all, do the first thing, find g inverse of x. G of inverse of x is equals to y minus 8. X plus 8 is equals to y, which in return is equals to the inverse of the function g. The second step is to find the inverse of the function f. So the function f tells us that, what does it tell us? So the function f is x is equals to y cube, x to the power 1 upon 3 is equals to y, which in return equals to f inverse of f. Now the main thing comes. So for part A, we are told find the expression of x such that it is equals to x minus 8 to the power 1 upon 3. So do we have x minus 8? Yes, we have gx in the form x minus 8. And if we input the inverse of the function f, sorry, if we input the function gx into the inverse of the function f, we are going to switch only the x value with the gx. So x minus 8, okay, and put this whole into 1 upon 3 as a power. So that would mean that fulfills the requirement. So our answer is in the inverse of function f. Hey, wait a second, let me see. Yes, so the value of gx to be input into the inverse of the function f. So that's our answer for part A. For part B, so as I've told you, even I'm getting a little confused in this, even though I've practiced these a lot. So you need to have a lot of practice for this because it's confusing again. Okay, so what's next? Next is that we need to find the composite function equation for which x has the expression of x cubed plus 8. So what do we have? X plus 8. Do we have x plus 8? Yes, we have the g inverse of x to be x plus 8. Okay, that would mean if we input x cube into this whole equation, that then we would get that answer. And which one is x cube? The function of f. So we are going to say that if we input the function, sorry, yes, if we input the function f into the inverse of the function g, we would get the answer, as that would be equals to input the function x cubed plus 8. Yes, that's the answer. So that would be the final answer. Okay, for the third step, we have to find x if it has expression x to the power 1 upon 3 minus 8. Okay, so what would be the solution? X minus 8. First of all, we can see clearly. So it's gx. And we have to input x to the power 1 upon 3 in this equation. So what's x to the power 1 upon 3? It's f inverse of x. So that means if we input f inverse of x into the equation gx, we would get the answer. So g f inverse of fx is equals to our answer. Okay. Now next step is part D. And part D tells us find the expression of x such that x plus 8 to the power 1 upon 3 is the answer. And for that we have, what do we have to do? 1 upon 3 here, and we have x plus 8 is g inverse, x to the power 1 upon 3 is f inverse of x. So for that, what we are going to do is input the value of the x plus 8 into x to the power 1 upon 3. So if we just switch x value with x plus 8 and we input this, we will get what we have been required in the question. So we are going to say that if we are going to input the value of g inverse into the function which is the inverse of f, we are going to get our answer. Okay, so that's it. We have completed exercise 1.6 for today, and I will meet you in the next lecture with again exercise 1.7. Exercise 1.7 is again a graphical exercise, so I think it's going to take a little longer than how we solve the rest of our exercise. So that's it for today. Thank you.